You know, they're everywhere. They march across our hills, they span our rivers, they line pretty much every highway. They're the silent, steel giants of our world. But here's a question. Even though we see them all the time, how much do we really know about them? Well, today we're going to dive in and uncover the amazing engineering story that's been hiding in plain sight this whole time. Seriously, think about it. Next time you're on a road trip, just take a closer look. You'll start to realize that these things come in a whole variety of shapes and sizes. And it's not random. Nope. Every single design tells you something really specific about the job it's doing. Okay, but before we get into decoding all the different shapes, we gotta start with the basics. What is the one single fundamental job that all of these giants on our landscape are built to do? At its heart, this is it. They are literally the backbone of our electrical grid. Their whole purpose is to take enormous amounts of power from where it's made, a giant power plant or a dam, and carry it safely, way up high above the ground, across huge distances to substations. Those substations then get it ready to send out to our homes and businesses. So when you boil it all down, every single tower is doing one of two main jobs. It's either just kind of chill, holding up the weight of the wire, or it's built like a tank to pull against the wire's incredible tension. And this right here is the absolute key difference. Suspension towers are the most common ones you'll see. Think of them as the marathon runners, just carrying the wire's weight in long straight lines. The dead giveaway? Their insulators, those ceramic or glass discs, hang straight down. Tension towers, though, they're the anchors. They're the heavy lifters you see wherever the power line has to turn a corner or come to a stop. Because they have to literally pull against all that tension, they're way beefier, and you'll spot them because their insulators are held out horizontally. So just how common are those suspension towers? Well, on a typical long, straight stretch of power line, a staggering 90% of the structures can be the simpler, lighter, and, cheaper type. The heavy-duty tension towers, they're saved for when they are absolutely necessary. So we've covered what they do, now let's get into what they're made of. See, the choice of material and the design, it's not random at all. It's a really careful balancing act between strength, cost, and, even how they look. So engineers have to weigh all these options. The classic steel lattice tower, that's the one you probably picture first. It's pretty much the industry standard. It's strong, it's cheap, and you can assemble it right on site. The downside? Well, they need maintenance, they can rust, and let's be honest, they're not always the prettiest things to look at. Tubular steel poles, on the other hand, they have a much cleaner look and they resist corrosion better, but they come with a higher price tag. And then you've got concrete towers. They are incredibly durable, super low maintenance, but they're bulky, and once they're up, good luck trying to modify them. All right, now for the really fun stuff. Let's look at how these basic designs get pushed to the absolute extreme. We're moving beyond the everyday towers and into the specialists, the ones built for some very specific and very challenging missions. If you've ever seen those absolutely massive towers on opposite sides of a big river, you've seen these guys. They have to be ridiculously tall to make sure ships can pass safely underneath the wires, and they have to be exceptionally strong to handle the strain of that huge unsupported cable span. These things are true marvels of engineering. Okay, this one's a little more technical, but it's so clever. On really long AC power lines, the 3 different phase conductors can get, unbalanced. So a transposition tower is basically a built-in wire shuffler. It systematically rotates the position of the 3 wires, kind of like braiding them over a long distance, which keeps the load perfectly balanced and makes the whole transmission way more efficient. You've definitely seen these running alongside train tracks, and they look a little different from the big grid towers, for a good reason. They're serving a totally different system. Railway power is a 2-pole AC system, not the 3-phase system our main grid uses. So their towers are designed to carry wires in multiples of 2, powering the trains right below them. All right, get ready for our great little party trick for any engineering nerd or, anyone who's just curious. You can often figure out what kind of electricity a tower is carrying just by counting the wires. It's all about spotting the difference between AC and DC. So almost every tower you see out there is carrying AC, or alternating current. Our grid runs on a 3-phase system, which means you'll always see conductors in groups of 3. 3 wires, 6 wires, 9 wires, you get the picture. But for super long distances, DC, or direct current, is actually more efficient because it loses less power along the way. These DC lines are much rarer, but if you ever spot a huge tower with just 1 or 2 massive conductors, chances are you're looking at a high-voltage DC line. Pretty cool, right? And just when you think these structures are all about pure function, you find something amazing like this. To reduce the visual impact in a really scenic part of Tibet, engineers didn't just build towers, they built art. They actually designed them to look like the region's native sheep and goats. I mean, how cool is that? It's just a stunning blend of powerful engineering and real environmental awareness. So you see, these towers are so much more than just steel poles holding up wires. They tell a story of our challenges, our ingenuity, and our relentless need for energy. And as our whole grid keeps changing with new power sources and new demands, you just have to wonder, what kind of story will these unseen giants tell us tomorrow?
We are FMG Tech. Contact us for more information. Visit fmg-tech.ir.